Welcome to the Alpha Training and Consulting's online training program. Today I'll answer the question, what is a standby reliability enhancement? Keep us in mind for all of your ASQ certification preparation needs. We'd love to have you as one of our students. It would be a great honor to us. So please consider us for those needs. All right, let's get back to the lecture at hand. In this module, we'll discuss one scenario which is described below, standby reliability enhancement. Okay. So if the reliability enhancement component is ineffective, then the block diagram is represented shown below. So what you're doing here is you're adding something that promotes the reliability of the system. Maybe it's an oil additive or something like that. Okay, you get the point. But you add something to the system that improves the reliability. But if that is not there, then you have this block diagram. So you have a series parallel mechanical circuit, if you will. All right, now we will add reliability values to the different components. There they are. And notice we do have an enhancement here. This block diagram represents the state of the system when the enhancement component is functional. So when this is functional, we will analyze it like this. When it is not functional, we will analyze it like this. Okay, so hopefully that's helpful. All right, and this gets a little bit tricky, by the way. You'll find out here in a little bit. So remember how we calculate reliability of parallel systems. It's 1 minus reliability 1 times 1 minus reliability 2, and if we had a third parallel component, it would be 1 minus the reliability of that one. Now remember, 1 minus reliability is failure rate, so you could say 1 minus failure rate of 1 times failure rate of 2, etc. But I put my diagram in terms of reliability, so we'll subtract it. So that's how we analyze these parallel systems. 1 minus the failure rate of 1 times the failure rate of 2 times however many failure rates you have in parallel systems. So hopefully that makes sense. So I go ahead and I multiply that out and subtract it from 1, and I get, for this part of the system, 0.9976. Then I do the same thing for this system. I get 0.993. That simplifies into a series circuit, which, as you know, to calculate series, this working and this working, you multiply the two together and it gives you the reliability of this system when the enhancement is functioning correctly. Okay. Now we will calculate the probability of failure if the enhancement component is functional. So probability of system success when keynote component is functional, which we just calculated. So the probability of the system failing when the enhancement component E is functional is 1 minus 0.9906, which is 0.0094, would be the failure rate or probability of failure. Now we will calculate the probability if the enhancement component fails. So maybe you changed the oil, but you didn't have any of this additive, so you have to run it without, for example. All right, very good. This one isn't very hard. You multiply these two, simplify it into a parallel system, and you go from there. So I multiply 0.96 times 0.90 gives me 0.864. 0.94 times 0.93 gives me 0.874. I put those in their parallel places, and then I solve it accordingly. 1 minus 0.864 times 1 minus 0.874. I take that product, subtract it from 1, it gives me 0.983. So there's my probability of success when my enhancement is not working or is not present. So the probability of failure when the enhancement component has failed is 0.017. Now we will have all the values necessary to calculate the reliability of the original system. Okay, this is where it gets a little bit crazy, okay? By the way, we call this a keynote component in many books, or reliability enhancement is what I've been calling it. Some people call it keynote component. I just wanted to make that clear. Before we can calculate the reliability of the system, we must first explain a theorem that has been named Bayes' theorem. So that's what's necessary in calculating the reliability of the system as Bayes' theorem. What does Bayes' theorem say? The probability of system failure is the probability that the system will fail if the keynote component is good. We've already calculated that, remember? Multiplied by the probability that the keynote component is good. Okay. And plus the probability the system will fail if the keynote component is bad, multiplied by the probability that the keynote component is bad. Wow, that's quite a bit of verbiage there, isn't it? Let's just do it. It's not really that bad. But I've wrote down everything we need. I put it in mathematical form, which is much easier to understand. So probability of success of this system is the probability of success if E is good, E meaning my keynote component or enhancement, the oil additive, for example. Probability of E is good, okay, plus the probability of success if E is bad. We've calculated that. Probability E is bad, okay. So that's all you need to do. I've written down everything we need here. We already calculated the probability of success if the enhancement is good, 0.9906. Probability of enhancement is good is 0.97. We already knew that. Probability of success E is bad is 0.983. Remember, we already calculated that one. And probability E is bad is 1 minus 0.97 or 0.03. Now that we have all that, we can put that into our Bayes' theorem calculation here, and we get a reliability of this system with the enhancement there of 0.9904. So the reliability of the system is 99.04%. Okay, at a given point in time where these probabilities were at. So maybe this is operated for 500 hours, then that would be the reliability at 500 hours. All right, hopefully that was helpful. If you have any questions, please let me know. And of course, keep us in mind for all of your ASQ certification exam needs. Notice we have a lot of them here. Today we talked about reliability engineering. We have a great class for reliability engineering at www.asqcre.com. And of course, we have a website for every one of our other classes. So check those out if you're interested. All right, congratulations, you have completed this module. I hope you have learned something new that will enhance your career. Thank you and have a great day. Goodbye.